Good morning, grade 7. We are still in the activity part of Module 1, weeks 1 to 4, okay, for the fourth quarter, entitled The Philippine Environment and Its Resources. And upon checking on the previous activity that we have, okay, only again 3 attempts. Yes, the last time that I checked, this is still 3 attempts. Anyway, can I ask you this? Um, do you want to take this activity or not? Those who didn't actually doing their or attempting their activity, do you want to do this activity or not? Yeah, I understand, Kaiser. How about others? There are a lot of online students here that didn't actually attempt the activity. This is 85 items. Because it will be useless if I will open this again and you will not do it in your own end. Okay. I will be opening this again for the last time. Take note, for the last time. And I will not be opening this again. This will be the last time that I'll be opening this. This is 85 items. Okay. All in all. This will be the last time that this will be opened. Right? Okay. I will assign this to RJ. RJ,
Yes.
after the class, please post in our GC that I am opening activity number 3 for the last time. And those who will not do their or they will not attempt to do their activity, we cannot do something about them. You tell them directly. Okay? Again, this will be the last
Okay.
time that I'll be opening activity number 3, concept analysis. Since we'll be moving forward, we still have activity number 4. Okay, I'll be giving activity number 4 by next meeting, hopefully. As what I had promised yesterday in your computer class, I'll be giving you examples for your learning resource material. Okay. So again, let me reiterate what we had discussed or agreed upon with your learning resource material. Okay. You create a learning resource material out of our topic for the fourth quarter, Module 1, weeks 1 to 4, entitled The Philippine Environment and Its Resources. Okay. So there are a lot of concepts under that subtopic, right? So you have 2 categories for your project. First is the digital output, and the second is the physical output. I already given you the example for the physical output. I sent it in our GC. Okay, those are outputs from my previous students. Now I'll be giving you examples for the digital output. So digital output includes but not limited to number 1, blogging, and number 2, video documentaries, narrated. So let's start with blogging. Okay. Let me share this to the class. Hold on. Okay.
Hello everybody, it's me, Kaylee Maxine Velosa, and for today we're going to be talking about a very interesting topic, gas laws. Let's start fresh. What are gas laws?
Well, gas laws are examples of scientific laws. These are statements that describe, summarize, and predict a range of natural phenomena by means of repeated experiments and observations. Gas laws are laws that relate variables pressure, temperature, volume, and amount mathematically in order to make predictions about gas behavior, which is given in the kinetic molecular theory. Now, let me briefly introduce to you the gas laws and some of their real-life applications.
Formulated by Robert Boyle in the year 1662, this law describes the relationship between volume and pressure, claiming that the two variables are inversely proportional, which means that when the exerted pressure of a gas increases, the volume it occupies decreases, given that the temperature and amount is held constant. So when one goes up, the other goes down.
Deep-sea creatures are unlikely to survive on the surface of the waters because they are used to high pressure. Once they are brought up, decrease of pressure allows the gases in their bodies to expand, causing their air bladder and cells to rupture.
Charles's Law, proposed by Jacques Charles in 1802. Given that the pressure is held constant, a gas's absolute temperature and the volume it occupies is in direct proportion, which means that what happens with one variable also happens to the other. An increase in temperature causes a corresponding increase of volume.
This law can be applied to baking. If you want your bread and cake spongy and soft, you would need yeast. Yeast is a leavening agent that converts sugars in the dough to carbon dioxide. Once the dough is put into the oven and baked in high temperature, the dough's gas expands, resulting to a spongy soft appearance for your pastry.
The relationship of the temperature and the pressure of a gas is described in a Montan's law, discovered by Guillaume Montans in the late 1600s. Just like the previous law, this law also describes a direct proportion relationship. When the temperature of a gas increases, while the volume is held constant, it causes the pressure to increase too. He discovered this while building an air thermometer.
According to Montan's law, higher temperature results in higher pressure. The air pressure in tires increases as the temperature rises.
Driving excessively raises the temperature of the air in the tires. Doing that, especially in this hot weather, may blow up your tires due to overinflation. Better get your tires checked to avoid risky scenarios.
A pressure cooker is a cooking device that cooks food quickly. While the food is being heated inside, its fixed volume container traps the steam being generated, and as steam builds up, the pressure increases. This law is simply a combination of the three primary laws we just tackled. There are specific events that involves the variables temperature, volume, and pressure. Hence, requiring a combination of the three laws caused the discovery of the combined gas law.
Our lungs are the containers that hold air. As swimmers dive in the depths, they make sure that they know how to adjust to maintain proper pressure balance between their lungs and the water. Because the water pressure increases, and like stated in Boyle's law, volume will decrease. And applying Charles' law, diving in cold waters may squeeze your lungs until there's no air left for you to breathe. Same goes with diving on a warm weather. The volume of air in your lungs may expand quickly. Without exhaling, the air will build up inside.
Proposed by Amadeo Avogadro in the year 1811. This law states that under the same temperature and pressure, equal volumes contain an equal amount of molecules.
When blowing up balloons, the volume increases as you release gas particles into the balloon from your lungs. The balloon's volume will expand as you force more gas particles to it.
Just like the combined gas law, but the Avogadro's law is added. Scientists wanted to study the relation of gas molecules to its environment, but upon brainstorming for the perfect equation, there are always affecting factors such as intermolecular forces. So, they just came up with this gas equation to study gas behavior, despite some minor factors.
Airbags installed in cars is controlled by a sensor that detects a crash. When the car crashes, the controller alerts the system, triggering an inflator that burns chemicals such as sodium azide very rapidly to produce large volumes of gas to inflate the airbag. While this happens, the bag is also being compressed when deployed, decreasing its volume, resulting to its pressure to rise. However, the gases are being neutralized to prevent the bags to overinflate. And seconds later, after the deployment, the bags will start to deflate in order for you to get out of the car.
Lastly, we have the Dalton's law of partial pressures, discovered by John Dalton in 1801. This law states that the total pressure exerted by a mixture of gases is equal to the sum of the partial pressures of the individual gases.
This law is especially applied to atmospheric studies. The atmosphere is made up of gases, mainly nitrogen, oxygen, and carbon dioxide, and water vapor. put together all the partial pressures of these individual gases, we get the total atmospheric pressure. Now you know the basic concepts and applications of these gas laws. I hope you learned a thing or two from this video, and I hope you understand the importance of these laws. Studying gas laws are important simply because these gas laws apply to our everyday lives. You may not realize the things you feel, see, hear, and smell can be explained by gas laws. These can even save your life. Till next time.
All right, that is one good example of logging, okay, under digital output, okay, logging. So most probably, what had you observed in the video?
She's explaining.
Yeah, that's a good observation, RJ. She is explaining about the concept. What else?
Gas laws.
Yeah, the concept of gas loss is there, correct? What else?
She uses animations.
Uses animations. Yes, that's a good
And
also
actually films in real life.
correct. So again, your videos, okay, your video documentaries and your blogging should number one, okay, explain the concept, unlock the difficulties of the said concept. Number two, it should also include practical applications. Have you seen the practical applications there? Okay. What are the practical applications of this? Okay. Of that said concept. Lastly, number three, it should be 5 minutes up. Okay. Not more than 30 minutes, but it is 5 minutes up. Right? That is one good example of a video a blogging. Let's move now to a video documentary. What could it look like be? No, when we have our video documentaries. Hold on, let me share this to the class. Video documentaries. This is one good example of a video documentary narrated. Please take a look at this one.
Over the centuries, experts have been studying something that is unseen in our naked eyes, and that is gas. And since it is different from more visible things, studying this element is more difficult. For that reason, scientists came up with some things that are helpful for them to study gas itself, and those are the gas laws. Additionally, there were plenty of experts who have formulated their own gas laws, and each gas law has their own uses. However, how can we apply this in our daily lives? Let's find out in this video. This is Christian Inario, and you're watching Science Matters. Studying science is interesting, and this makes us formulate a lot of questions. For this topic, we tend to ask, what are the applications of these laws in our daily lives? To begin with, we will talk about the Boyle's Law. This describes how the pressure of the gas tends to increase as the volume of the container decreases. According to the rule, if the volume is large, the pressure is low, because the particles cannot move quickly because they must move in a large container. On the other hand, if the volume is small, the pressure is high, because the particles must move in a smaller container. You can observe a real-life application of Boyle's law when you fill your vehicle tire. As you push air into the tire, the increasing pressure reduces the volume of the air molecules by packing them together. The pressure in the pump has to always be higher than that which is inside the tire in order for more air to be pushed in. As the air temperature is more or less constant in that period of time, you can see a real-life example of Boyle's law occurring in front of you. We are down to our next law, and that is Charles' law. This law describes how gases tend to expand when heated. According to the law of Charles, volume and temperature are directly proportional to each other. A real-life application of Charles' law would be your vehicle tire. If you read your owner's manual carefully, it will mention that tire pressure should always be measured cold. That's because driving around heats up tires. Charles' law states that a gas should always occupy more space when heated. But a tire does not expand very much. This causes the tire pressure to be higher when warm. Consequently, measuring tire pressure when the tire is warm will give you the false impression that you have filled your tires with too much air. Now, we are going to discuss our third gas law, and that is the Avogadro's law. According to this law, the same amount of gases at the same temperature and pressure emit the same number of molecules, regardless of their chemical and physical properties. In other words, as temperature and pressure remain constant, the volume of the gas is directly proportional to the number of gas moles. Real-life evidence of this law is whenever you blow up a balloon. The volume of the balloon increases as you add moles of gas to the balloon by blowing it up. Basically speaking, the more moles, the larger the volume will become. Now, we are in a Monton's law. This law states that the pressure of an ideal gas varies directly with the absolute temperature when the volume of the sample is held constant. This means that lower temperature means lower pressure, and higher temperature means higher pressure. A real-life example of this is your vehicle tire. In hot summer days, the inflated tires of vehicles may burst. The bursting of tires is caused by a Monton's law. The inflated tires are under high pressure. When the temperature of the air rises, the pressure of the gas in the tubes also increases. After an unbearable point, the tires fracture. However, what makes gas law important? Actually, gas law make the studying of gases much easier. They can be used to determine the parameters of a mass of gas using theoretical means. For that reason, these said gas laws are truly of great importance, and I do believe that they are useful when studying the things that are not seen. Remember, there are still gas laws out there not being mentioned here. For that reason, I encourage you to do your research and be limitless. This has been Christian Inario, and always remember that science matters.
Okay, that is actually one good example of a video documentary, narrated one. So those are two examples of your project. And hopefully you are now starting doing your project simply because, again, the deadline is in the May 13th or 13th of May. So it's really near. You still have around 2 weeks more to go. Okay, 2 weeks more to go. And I'll be checking your outputs for this school year. By the way, RJ, can I ask
Yes.
a favor to you? Please post in our GC, tell your classmates that I am in the middle of checking all your activities for the fourth quarter. I am just waiting for the fourth periodical tests and your project for this school year. Okay, your learning resource material. Okay, please inform them via GC. Inform them that I am in the middle of recording all your raw scores. Okay, and I am just waiting for the fourth periodical tests and for your learning resource material. By the way, again, for your learning resource material, include, okay, the practical applications, number 1, and the uses. Please also include the concept. It should explain the concept itself, okay, the science concept that we have. And lastly, it should be more than 5 minutes, but not more than 30 minutes. More than 5 minutes is good. Why? If you're going to make it in a 30-minute video, it will make your video boring. Okay. Our main goal for this project is to what? Is to explain the science concept and again to inform your viewers about the practical uses and applications. Right? Do you have any questions so far?
No.
Oh,
Okay. Again, reminding everybody about your activity number 3, concept analysis. Please do it now. Okay, I will not open this again simply because we'll be moving to activity number 4 by next meeting. Right? I think I'll go for today, class. Thank you for your participation. Grade 7. Let me check on your attendance. We have Travis, RJ, J. Rus, Kaizel, and Levi. Okay, Levi, please inform also your other sibling to contact me ASAP. We need to agree upon together with your advisor, okay? Please send me a PM, a personal message. Levi, can you hear me? Okay. Please send me a personal message. We need to agree upon. Okay. I think I'll go for today, class. Thank you for your participation. Grade 7. Have a nice day. Take care, everyone. Bye-bye.